Good morning, dear students. This is October-November 25 variant 42 or 32 and question number 4. A student investigates the rate of cooling of hot water in a beaker. Okay. Now, plan an experiment to investigate the relationship between the thickness of the cardboard insulation wrapped around the beaker and the rate of cooling of hot water in the beaker. So, a beaker will be given here, and then there is a cardboard roll for the insulation. See, there's the image. I try to give a clear example here. Is a beaker. There is a 1 millimeter thick cardboard around the whole beaker. Okay. The apparatus available includes the supply of hot water, a beaker, a thermometer, the supply of 1 millimeter thick cardboard sheet. Okay. You are not required to do the experiment. In your plan, include any other apparatus needed. Okay, we will start the experiment. Rate of cooling of hot water in a beaker with different thickness of cardboard insulation. So 1 millimeter thick cardboard is given. So initially we will do it for 1 millimeter, and then we will do with the second cardboard, which is 2 millimeter, means 1 plus 1, 2 cardboard, 3 cardboard, and we will measure every time. We will measure the rate of cooling. First of all, see here 1, 2, 3, 4, 5. See, in this question we have 6 marks. So mark segregation you need to, it's very important. First mark, any other apparatus needed. What do you think? Yes, it is. Apparatus stopwatch is not given here. So first of all, you will write additional apparatus is stopwatch. Number 2, a brief description of the method, including what you will measure and how you make sure that your measurements are accurate. Okay, what I did here, description: put hot water in the beaker, which is wrapped with 1 millimeter thick cardboard, and then record the initial temperature with a thermometer and start the stopwatch. After 5 minutes, record the final temperature of the water. Now, by subtracting the final temperature to initial temperature, we can calculate the changing temperature. And finally, by dividing with the time, we can calculate the rate of cooling of hot water in a beaker. Okay, one experiment is done. Repeat the procedure using more number of cardboard and find the rate of cooling. Okay, second point done. What about the third point? The variables you will control, means the constant in this experiment. What are the variables we need to keep constant? The first one, what I thought, the same initial temperature of hot water. Every time we will start the experiment, the initial temperature, suppose we are going to start it with 80 degrees Celsius or 90 degrees Celsius, every time it will be 80 or 90 degrees Celsius. Or you can write here the same volume of water. Definitely for the same experiment, the volume of water needs to be constant, or the same mass of water. If volume is constant, definitely mass will remain constant as well. Same time of cooling, definitely I took here 5 minutes for each experiment. And then there is the third point, fourth point, data table. So what is the data table here? Definitely the number of cardboard. I am increasing 1 millimeter thick cardboard, 1, 2 and 3. And then see here initial temperature is constant for the whole experiment. So in the table, it is not necessary to add it. So I can use the final temperature, yes. And then by subtracting the final temperature to initial temperature, we can calculate the change in temperature. And the rate of cooling means divided by del theta, the amount of time here, 5 minutes, so 5 into 60. And then with unit is very important, very important. You need to give unit every time. The first one is degree Celsius and the next one is degree Celsius per second. The next thing is how you will process your result to reach a conclusion. It's a very important conclusion. So what we need to do? We will take here 1, 2, 3, 4. That's it. So after that, we need to plot a graph. Plot a graph of number of the cardboard against the rate of cooling of the hot water and find the correlation between them. So this was the answer. And this is the diagram. So thank you. Bye bye.